Hi guys, my name is Daniel, and today I'll be presenting my project, which is a classification application on YouTube. So let's look at the task motivation. Image classification is very far along. While much less work has been done with audio classification, I think this is primarily done because there are far fewer data sets and it's much easier to understand images than it is to understand audio. But there are wide-ranging applications of audio, surveillance systems, multimodal embodied environments, and one that I'll be focusing on, which is like improving audio recommender systems, for example, Spotify. And so for this part, I focused on music classification. So for this music classification, I use somewhat of a toy data set, which is the XAM data set. It's an old data set. It has 10 classes consisting of classical, pop, hip hop, and a bunch of others. There's 100 samples per class. Each audio clip is 30 seconds and it's mono audio, which means that it's only one channel and it's sampled at 22050 hertz. We also split this data set into 70-15-15 train valid test splits. So for our network, we have to do some audio processing once we load it in. So it's harder to use raw waveforms because like the shape and structure are fundamentally different from like images, because like waveforms are very like kind of sequential-ish and they're long and very narrow. And to change that, we use a short time Fourier transfer to create these spectrograms. And STFT is it's like a way to transform your waveform into a visual representation, and it does it by it's kind of like FFT but over a small window. And in the spectrogram, the axes are time on the x-axis, frequency on the y-axis, and how bright it is based on the amplitude of that frequency. And yeah, we pass this into our network. So we see that the spectrograms are visually similar to images, kind of. So we can use image models to try and classify these. So in this model, I use ES-ResNet, stands for Environmental Sounds ResNet. And this is a modified ResNet 50, pretty much for um, purposes of audio classification. Next, I had to train the model, so I compared two different ways of training. So because it is a modified ResNet 50, I can preload the ImageNet weights, and I can train end-to-end from scratch. And we see that fine-tuning the ImageNet weights just outperforms training from scratch like easily. And I think it's because there's a lot more variety and the features are much more defined with a larger data set. So now we look at our results. Our peak accuracy on the validation set was 78%, and we used that to do our test accuracy, and that was 68% test accuracy on 150 images, which is 10 classes by 15 in each set. So our metrics that I pretty much use precision, recall, and the F-score. So precision is like the true positive over true positive plus false positives. Recall is true positive over true positive plus false negatives, and then F-score is like a harmonic mean of the two. And we look at the F-scores for each class. We see that like it has trouble looking at blues, reggae, and rock, and really badly. And then the next ones, we see that are country and jazz. But I want you to look at the heat map on the left. The reason why country's F-score is kind of low is because we see that its precision is very low, because a lot of other classes get thrown into this second column with country, and then for jazz, the reason why it's low is because its recall is low, just because it only has 7 that it predicts accurately. So we see that F-score can take advantage of like over predicting and under predicting relatively okay. Next, so the last part is I made a quick web application with Flask, and the steps are you enter a YouTube link, the video is downloaded, and then we take like 16 30-second random samples from the video to match our inputs. Our clips are fed through the network, and the softmax scores are averaged, and we show the top 3 class and probabilities. So I'll show you my quick application. It's a Flask app, and it's pretty relative. It's an easy user interface. So we go on our, let me just get a YouTube video queued up, like Beethoven's Moonlight Sonata. So if we take this YouTube, this is what it looks like. And now let me just put that YouTube link in. It's It's fairly classical, and the network should predict so. The network doesn't do as well on other videos though. Yeah, so it wasn't too long, and we see that with it predicts classical with pretty high accuracy, and yeah, so that's just a quick link on how it works. So I also have it run on this website, YouTube Music Classifier on render.com. It doesn't work as well just because there's some problems with downloading files on this web server. And but yeah, that's my presentation. Thank you.